that word electrochemical cell. They can be electrolytic cells in which the chemical energy is brought about by electrical energy, or electrical energy is supplied to bring about a chemical reaction. And there are galvanic or voltaic cells, cells in which a spontaneous chemical reaction is bringing about electrical energy. This is what we use as batteries. Kirti, please switch off your mute yourself. Okay, now. So that's what we were trying to tell. And yesterday we have dealt in depth about the construction of electrochemical cells. Actually, you'd be surprised. We have not really jumped into the syllabus, exact syllabus, but these are very much important prerequisites for your clarity of the subject. Once you get the clarity, we can just change the gear. Okay. So then I was like concluding the session, and your friend asked me a question: why lithium-ion batteries for a period of time, okay, do not give the power properly, and sometimes they undergo bulging. That's what we sometimes see, that the battery would bulge. Okay, here the whole construction and the working of the lithium-ion battery I'll deal in depth in when I'm talking about the session. But you should remember that in lithium-ion batteries, the electrodes are, answer my question. In lithium-ion batteries, the electrodes are active electrodes or inert electrodes?
Active.
Inert.
Inert, ma'am.
Inert. Active or inert? When you would say the electrodes are active, and when you would say the electrodes are inert?
While charging they are active, while not charging they are inert.
Okay.
When they are participating in electrochemical reaction, active. If they do not participate, then they are inert.
Yes, correct. In lithium-ion batteries, they are inert. I'll take graphite rod in which the lithium is impregnated. Okay. And there's one more graphite rod on which cobalt oxides or transition metal oxides are impregnated. And during the working of battery, that is discharging, the lithium ions move from anode to cathode. That is the only activity that is taking place. You'd be surprised. That's it. Okay. And when recharging is being done, the lithium ions move from cathode to anode. That's it. Li plus ions. And the electrolyte is actually non-aqueous, because once any drop of water, it will explode, of course. They are the organic compounds. Okay. Now, how the lifespan of a lithium-ion battery is estimated. Okay. The life cycles are many, but what you should realize is that in lithium-ion batteries, the moment you switch on for the charging, what you will realize is that one cycle is done. That means if you do charging for 1 hour or 1 minute, once the activation is done, that is, you're doing charging of the battery, one cycle is over. Okay. Why? It's all about the movement of ions from anode to cathode and vice versa. Okay. And hence is the fluctuation in the lifespan of the lithium-ion batteries. Okay. Along with that, the composition of the electrolytes, okay, and the number of times you're doing the recharging of your battery and the length of the time. That's the reason why they would say, do not keep the battery overcharging. That means we should never ever keep the battery for long hours. Why? Because in the whole process, what you'd be realizing is that the movement of lithium ions from anode to cathode and vice versa is the only activity that's exactly happening. The rest all are just supporting the process. That's the versatility of the lithium ion batteries. Okay, but what you should realize is that it's all about the adsorption of the lithium ions over the inert electrodes. And each time, if the number of cycles which are defined for that particular battery or its capacity is defined by how many times you have just plugged in and plugged off. That's it. That's the uh, importance of lithium ion batteries. Any uncertainties or by chance if water enters or any such activity is happening, though it is insulated, what would happen is the solvents which are acting, actually they are not liquid solvents, they are organic compounds which are acting like electrolytes and supporting the reaction would undergo changes, and hence the bulging of the battery takes place. We'll study all these things in detail at the end of the session. This is there very much in your syllabus. Okay, and I'll get back to my subject of discussion. So after understanding the construction of electrochemical cells, and I've told you the lithium ion batteries are exactly opposite to lead acid batteries, what we'll be using for our car batteries and all. There actually it's all water, water and water. The electrodes are active electrodes, they are participating in the electrochemical reaction. Okay, so these are the two things which I felt you should know it practically and understand. Of course, we shall detail that also because it's there in your syllabus. Okay, now I've understood about the electrochemical cells. That part is also done. Now, what's the next thing is, what are the factors that affect electrolytic conduction? By this time, we have clarity that electrolytic conductance is due to movement of ions to oppositely charged electrodes. And we have understood that the ions are present in the electrolyte, or electrolyte is the solution which has ions which would move to the oppositely charged electrodes. And electrodes are the medium for the flow of electrons. And always by IUPAC convention, anode is on the left hand side and cathode is on the right hand side. Anode is what electrode? Anode is what electrode?
Negatively charged electron.
Oxidative.
Which is the correct answer? Next question. What is cathode?
Reductive electrode.
Reductive electrode. Is the definition correct or wrong? If anode is positively charged, cathode should be negatively charged. Where and when? Would you like to answer?
In electrolytic cells, anode should be positive, cathode should be negative. In galvanic cell, anode should be negative, cathode should be positive.
Correct. Good. Right answer. What is anode and what is cathode? Ante entavi. In Japan.
Anode is nothing but where oxidation takes place, and cathode is nothing but where reduction takes place.
Ante. What is oxidation, Tarun?
Oxidation means loss of electrons, and reduction means gain of electrons.
That's it. So if someone asks what is anode and what is cathode, it is a thumb rule. Anode is a place where oxidation takes place. Cathode is a place where reduction takes place. And total loss of electrons, other places gain of electrons. That's it. That's the discussion. Okay. So where the ions are coming from, the electrolyte, and these ions are moving to the oppositely charged electrodes, and they are actually doing the. Naveen, mute yourself. Would you like to ask some question or answer? Okay, then I'll just get back to my discussion. Now, what are the factors that affect electrolytic conduction. Okay, write the heading. Factors affecting electrolytic conductance. Factors affecting electrolytic conductance. Now by this time you need to tell me. It should be an interactive session. Roll number 81. Good morning.
Yes, ma'am. Good morning.
Good morning, Harshit. Tell me, what is your guess? Just and you can guess something. Let's be more interactive instead. Rather, I giving you taking notes becomes monotonous. Anyone can answer, but then the question is on you. Vintunava Harshit Leda? Harshit,
Yes, ma'am.
or is there? Then I've asked you a question. What are the factors that affect electrolytic conductance? Question. ఏదై ఉంటుంది?
Ma'am,
చెప్పాలి.
టెంపరేచర్ ఉండొచ్చు.
ఉండొచ్చు కాదు, ఉంది. I have a point to tell you all. Everybody can do it. It's no big deal. You should use your logic. Then when you will start using, when you have interest. Okay, it's for everyone. Everyone can answer. It's no like this is not a big theory that we are asking. It's a common thing. It should be an interactive one. What will happen if you don't know? Nothing will happen. You will know it now. That's it.
Concentration of ions, ma'am.
Concentration of
nature of electrolyte.
Nature of electrolyte.
Lovely. That's the answer. Inka? Temperature is correct.
Temperature.
Concentration of temperature, yeah, that's already told. Inka? Nature of electrolyte, correct.
Electrodes.
Power supply.
Electrodes.
Power supply.
Nature of electrodes.
Nature of electrodes.
Concentration of ions.
Concentration of ions and a concentration of solution, correct. Okay. Now we'll conclude. We'll make one conclusion, okay? And we shall discuss. Okay, so write the heading, factors affecting conductance. First one is type of electrolyte. Type of electrolyte. In brackets, whether strong or weak electrolyte. That's one. That's the first one. Okay. Concentration of the electrolyte. In brackets, whether strong or weak electrolyte. Okay. Then the second one is type of electrolyte. The second one is concentration of the electrolyte. Naveen, mute boy. Hey. Second one is concentration. Third one is charge on the ions. Charge on the ions. Fourth one is speed or mobility of ions. Speed or mobility of ions. That's the fourth one. Fifth one, temperature. Temperature. And the last one is cell constant. And the last one is cell constant. Okay. These are there are many more. Actually, your friend has told. The speed of ions depends upon the potential gradient that is applied. Okay. That's also very important. But we'll restrict our discussion to what we want. Okay. or the factors that affect electrolytic conductance. This is again the major viva was a question for explaining the 3 experiments what you have in your syllabus. Okay, so understood. Strong electrolytes conduct more current, weak electrolytes conduct less current. More the concentration, more is the number of ions, so more is the electrolytic conductance. Of course, the temperature affects conductance positively. Okay, in the sense that as temperature is increased, the dissociation of ions increase in the case of weak electrolytes, and in the case of strong electrolytes, the speed of ions increases. Okay, and also we know that fast moving ions conduct more current than slow moving ions. అంతేనా? అంటే ఏంటి, నువ్వు ఒక హైవే మీద వెళ్తున్నావు, మంచి బైక్ కొనుక్కున్నావు, చక్కగా హైవే మీద వెళ్తున్నావు, ఓ సూపర్ సూపర్ రైడ్. ఓకే, అదే లేదు మన బడంపేట రోడ్లోకి వచ్చావు, అంతా ట్రాఫిక్ జామ్. ఓకే, సో సో ఇట్స్ అ డిస్కషన్. అంటే ఏంటే fast moving ions conduct better current than slow moving ions. So then it's a discussion. What it means by cell constant. What it means by cell constant. Okay, so I know that I understood that by this time my electrochemical cell has a container in which the anode and cathode are placed parallel to each other. Okay, so what should be the distance between anode and cathode in my electrochemical cell? It can be anything. It can be 1 centimeter apart or 2 centimeters apart or any distance according to my convenience. Okay, and to tell how far those 2 electrodes, that is anode and cathode, are placed and how much is their area of cross section is given by a term called as cell constant. So what it means by cell constant? It's the ratio of the distance between the electrodes and their area of cross section given by the formula L by A, where L is the distance between the 2 electrodes, anode and cathode, and A is the area of cross section. Okay, and the units are centimeter inverse or meter inverse is the units of cell constant. And what's your guess? More the cell constant, less would be the amount of conduction. Why? The ions have to travel more distance for conducting the current. Okay, so that's the idea, right? Cell constant. Next point, cell constant. It is the ratio of the distance between the electrodes. It is the ratio of the distance between the electrodes and their area of cross section. And their area of cross section. Okay, understood? Units, centimeter inverse or meter inverse. Formula is small l by capital A. L by A. Small l by capital A. Roll number 92. Good morning.
Good morning.
Okay. Usha, Chipnana. Give me the definition of cell constant.
It is a ratio of distance between the electrodes to the area of cross section of the electrode.
Area of cross section of the electrodes, correct. It's given by L by A, units NT.
Units, centimeter.
Centimeter inverse.
Yes, ma'am.
Okay. So now I have a question to ask you. By this time, you have understood what would be the construction of an electrochemical cell. Okay.
Yes.
Now, you also accept that the concentration of the solution affects the conductance?
Yes, ma'am.
Yes. So to express electrolytic conductance, what I need to tell apart from cell constant?
This also
Ma?
if they
No, no. You have notes on hand with you?
yes, ma'am.
I told you electrolytic conductance is expressed in two ways. What are those two? Electrolytic conductance ni రెండు విధాలుగా నేను ఎక్స్ప్రెస్ చేయొచ్చు. What are those two things? I have already told you.
It depends on the type of
కాదు, నోట్స్ ఉంటే తిప్పు. Anyone in the class? What did I say? Electrolytic conductance is expressed in two ways.
Equivalent conductance and molar conductance.
Yes, equivalent conductance and molar conductance. Sarena? Understood? What I was trying to tell you there? What is your guess? Miran, see, one point I would like to tell you. See, if I tell this, you will understand. You will read it and apply it. Good. If I give a formula, you will substitute and do it. But now this is the time. What is BTech all about? This is what I should teach you. In fact, your age is such, I know. If you have that clarity, you'll just read notes, or you have videos on hand. Just browse them. You'll know the knowledge. But how to imagine this? This is what I was trying to tell you yesterday. ఏం చెప్పాను? ఎలక్ట్రోకెమికల్స్ ఎలా అంటుంటే మీకు ఏదో ఏదో అనిపిస్తూ ఉంటుంది. అదంటే మన బ్యాటరీ, రోజు వాడే బ్యాటరీ. That's all about engineering. It's like, it's not difficult. It is only how we put our brain. Sare, just now you told that the concentration of the electrolyte affects conductance. Okay, so it is not just like a metallic wire. I can tell that conductance is so much. Why? In metallic conductance, it's just flow of electrons from one end to other end against a potential gradient. Absolutely, there's no question of concentration of or any such thing. And where the material that is supplying current is hardly has any effect unless until it's all about the resistance it offers. That's it. Apart from that, the behavioral pattern is the same. But that's not this thing here in the case of ionic conductance. In the case of ionic conductance, we need to first know where it is taken. That is, we should know the cell in which it is taken. And I kept telling you, a cell is a combination of an anode and a cathode. That's the first thing. And how far those anode and cathode are there. That means I should have a clarity about the cell constant and what is their area of cross section, and whether those electrodes are participating in electrochemical reaction or not. That means whether the electrodes are active or inactive electrodes. I should also have an idea about the concentration of the electrolyte and the type of electrolyte, of course. So when you're expressing the concentration of the electrolyte, the conductance you're saying is equivalent conductance or molar conductance. What it means, if you are expressing, what are the units for concentration? Cheppandi. What are the units for distance?
Molarity, ma'am. Molarity, indirectly molarity equal to concentration. No?
Indirectly or directly, I need it. Good, that's the answer. Good, that's answer. Parts per million. Correct side. Correct. Good. Sorry. Let's come like this. What are the units of distance?
Kilometer.
Or like
Centimeters.
Meter.
centimeters, meters, millimeters,
meters.
meters. kilometers. Light years, is light years a unit for distance? Celestial objects. Space, celestial space, space fathoms, and large distances. Okay. Even depth of oceans fathoms antara? Can you fathom అంటారు అంటే ఏంటి? మనం భూమిలోకి వెళ్ళినప్పుడు fathom అనుకుంటాం. It's a unit. Okay. What are the units for weight?
Kilogram, gram,
Grams, kilograms, milligrams, kgs, etc. What are the units for volume?
liters,
Meter cube.
centimeter cube,
Meter cube.
Centimeter cube, meter cube, like that. So what it means by a solution?
Solute plus solvent.
Combination of solute and solvent.
And it should be homogeneous mixture. Kada? A solution is a homogeneous mixture of a solute and a solvent. Which one is a solute and which one is a solvent? The substance which is present in larger proportion is called solvent, and the substance which is present in lesser proportion is called as solute. Antena? Can a combination of oil and water make a solution?
No, ma'am.
No. Can a combination of water and alcohol make a solution?
Yes,
Yes, ma'am.
Yeah, ante solution ante pratisari it should be a homogeneous mixture. Okay. Okay, now I'll come to my point. So I have added solute to solvent and I have made a solution. So how I will tell the concentration of that solution? I took 2 glasses of water. In one glass I added NaCl 1 spoon, and in the second glass I've added 2 spoons of NaCl. Okay, both are salt solutions, fine. But I want to say in one glass I've added only one spoon, and the other glass I've added 2 spoons. So what I'm trying to express?
Moles per liter.
If weight of the solute is more, concentration will be more, ma'am.
సరే అదే చెప్పాలనుకున్నాను. అంటే ఏం చెప్పాలనుకుంటున్నాను? వాట్ ఐఎమ్ ఎక్స్ప్రెసింగ్ కాన్సన్ట్రేషన్ కదా. సో if I talk about solutions, what I'll express? Concentration of solutions. సరే చెప్పాలి. Okay, there is so many grams of NaCl in this glass 1 and so many grams of NaCl in glass 2. So what are the units I am trying to express? 1 liter of water లో దీంట్లో 1 స్పూన్ ఉంది, దాంట్లో 2 స్పూన్స్ ఉందని చెప్పాలనుకుంటున్నాం. అంటే ఎలా చెప్తాం? గ్రామ్స్ పర్ లీటర్ ఆర్ గ్రామ్స్ పర్ ml. So how the concentration of solutions are expressed?
moles per
Weight
liter,
by weight. Okay, weight by weight, weight by volume, or there are terms like normality, molarity, molality, mole fractions, etc., which express the concentration of solutions. So you understood what I'm trying to tell. So if I were to express the concentration of solutions, the terms that I use are milligrams per liter or grams per liter or grams per 100 ml, which is nothing but weight to volume or weight to weight. Like so many grams is present in so many kgs. Okay, that is weight to weight ratio or normality. Okay, molarity, like that. Okay, so these are the terms that are used to express the concentration of solutions. So I'll get back to my point. Now I know that for expressing the conductance of an electrolyte, I have to tell the concentration of the solution. So when I'm trying to tell the concentration of solution, so how I'll express concentration? There are 2 very commonly used concentration terms. One is normality, the other one is molarity. If you are expressing the concentration of the electrolyte in terms of normality, you will give equivalent conductance. Now, if you are expressing the concentration of the solution in terms of molarity, you are giving molar conductance. Okay, this is what is the whole concept about the ionic conductance. Understood? Fine.
Yes, ma'am.
Okay. So I'll get back to my discussion. Hope by this time you have written that. No, you already wrote that in electrochemical cells, we'll again classify it into two types: the electrolytic cells, and the other one is galvanic or voltaic cells. See, the electrolytic cells are not there in your syllabus. Okay, but then a brief idea about it and the experiment that is included under this I'll discuss today, so that I can go ahead with the main subject of discussion in another 10 minutes time. Okay, so because electrolytic cells are not there in your syllabus, I'll just concise my discussion to what is important for your lab. Okay, so what are electrolytic cells? What are electrolytic cells? Tell quick.
Which converts electrical energy into chemical
Electrical energy to chemical.
Electrical energy into chemical energy. Good. Okay. What are the applications?
When it is charging. Charging, madam.
Charging. Yes, charging.
While the battery is charging, it's.
అది నువ్వు రియాక్షన్ చెప్తున్నావు, అప్లికేషన్ అడిగాను కార్తీక్. Girls, you are not interacting, you are not liking my lecture.
It's used to produce oxygen gas and hydrogen gas from water.
Yes. Production of gases, correct. That's one of the application. Good. Inka, girls, what is this? You're not answering me. You didn't like my lecture. Come on, answer. We know it. We know more than.
It's also used for extraction of common salt, right now.
Yes, extraction process. Okay. Correct. And now, Manideep, you should improve now. First generation of gases, if we want, we will do it by electrolysis process. That's the first one. The other one is during extraction process. Okay, extraction of anything which we want. Okay, that means pure metals sometimes in metallurgical operations or any other processes. Okay, what else? In electroplating. In extraction of metals in electroplating against corrosion protection. What it means by GI pipes. You know it? Girls, we wear nice jewelry, is it not? The 1 gram gold jewelry and all. How you are going to get all those things? What in 1 gram gold? What is it? What is it that is being coated?
Gold.
Gold. Then దేని మీద కోటింగ్ చేస్తున్నారా?
Jewelry.
దేని మీద? What is the base metal దాని మీద? Copper? Think of some copper? Okay, that's the one. How it is coated and why it is important for us right now. Actually, electroplating is one of the major application of electrolysis process, which is very, very dictating in the particularly in the protection of metals as anti-corrosive properties. Okay, for their anti-corrosive properties. But what is important for EC students is, I think that might be there in your syllabus. Let me check. Electrolysis plating of copper and nickel. Okay, that is a different topic, so I don't want to mix it right now. How can there's a question I'd ask, and I'd just stop this topic. What is how copper is coated on plastic? How this PCB designing is done? What is PCB? You know it? You had BEE, is it not in the first set?
Polyvinyl.
Vinu question. నాన్న చెప్పిన మాట విను. PCB BEE చదివారా ఫస్ట్ సెమ్ లో? చదివారు లేదా? గబగబా చెప్పండి. BEE ఉండిందా మీకు?
ఉన్నది.
మొద్దులా మీరు
Printed circuit.
Printed
PCB.
circuit board.
Okay, correct. Printed circuit boards, correct. PCB design. దాంట్లో బోర్డ్స్ లో ఎలా ఉంటుంది? అవి ఏ మెటీరియల్ ఉంది? బేస్ మెటీరియల్ ఏముంటుంది సర్క్యూట్ బోర్డ్ లో?
కాపర్.
కాపరా? కాపర్ దేని మీద వేసి ఉంటుంది ఆ డిజైన్? సర్క్యూట్ డిజైన్ ఎలా చేస్తారు?
ప్లాస్టిక్.
ప్లాస్టిక్. ప్లాస్టిక్ మీద కాపర్ ఎలా వచ్చింది చెప్పు హర్షిత్. ఎలా పెడతావు ప్లాస్టిక్ ని కాపర్ మీద?
ఎలక్ట్రోప్లేటింగ్.
కాదు, ఎలక్ట్రోప్లేటింగ్ అంటే నువ్వు ప్లాస్టిక్ నాన్ కండక్టర్ ఆఫ్ ఎలక్ట్రిసిటీ కదా. ఇంట్రెస్టింగ్ కదా. అది ఎలా అంటే ప్లాస్టిక్ దాని మీద ఫస్ట్ ఎచ్ చేస్తారు ఏ డిజైన్ లో కావాలో అని చెప్పి చేసి, తర్వాత దాన్ని ఎలక్ట్రోలైట్ లో డిప్ చేసి ఏ మెటల్ అయితే నువ్వు దాని మీద కోట్ చేద్దాం అనుకుంటున్నావో ఆ ఎచ్ చేసిన ప్లేసెస్ లో ఆ మెటలిక్ సొల్యూషన్ ని డిప్ చేసి రెడ్యూసింగ్ ఏజెంట్స్ యాడ్ చేస్తాం. కాపర్ ని చేసామనుకో, కాపర్ ఏమో హెచ్ అవుతూ ఉంటుంది, రెడ్యూస్ అయ్యి. కాపర్ సాల్ట్స్ తీసుకుని రెడ్యూసింగ్ ఏజెంట్ యాడ్ చేస్తే ఏమవుతుంది? కాపర్ డిపాజిట్ అవుతుంది. నికెల్ వేసి రెడ్యూసింగ్ ఏజెంట్స్ వేస్తే నికెల్ అయాన్స్ రెడ్యూస్ అయ్యి నికెల్ కింద అది అవుతుంది. అలా డిజైన్ చేస్తారు PCBs, ప్రింటెడ్ సర్క్యూట్ బోర్డ్స్. ఓకే, that is one of the another major application of this electroplating. We'll not waste time now. Okay, it's not time waste, it is interaction, but then I have to focus on what I have to complete. Okay, so electrolytic cells are the cells in which the electrical energy is creating a chemical reaction in the electrolyte, and in this process the electrolysis takes place, and the ions would be moving to the oppositely charged electrodes, and it has umpteen applications, particularly in the metallurgical operations or electroplating process for corrosion control and various other applications. Generation of gases, as told by Manitip and all other applications. But then this is also very much used in our laboratory for finding the concentration of test solution using the experiments of conductometry. Okay, so I want to conclude that point about the electrolytic cells. Okay, I'll not extend much. Why? Is because it's not there in your syllabus. But then I have a point to tell. When aqueous solutions are taken, okay, so when aqueous solutions are taken and you are doing the electrolysis process, now which water has H plus and OH minus ions, and the solution has its own ions. Now which would get deposited where and how? How can you guess which ion undergoes change in the oxidation state and undergoes deposition preferentially? How can you guess?
SRP.
SRP value. What it means by SRP, Rahman?
Standard reduction potential.
What it means by reduction potential?
The ability to reduce.
Ability to reduce. Easy, right?
Ma'am, it depends upon electrochemical series.
Sorry, you are correct. Your points are correct, but I'll summarize it because I've been doing that for a quite long time. I'll do it in a better way. Okay, so which ion preferentially moves towards the electrodes and will get discharged depends upon their discharge potentials. Okay, and the discharge potentials of ions are predicted by a series called as EMF series, which gives SRP values of various metals, non-metals. Okay, That's the conclusion for electrolytic cells. Okay, and we shall talk what it means by SRP values and all in the next topic. Okay, so to conclude this set, right, electrolytic cells, point number
7, madam. 7.
19, ma'am.
19. Okay. Point number 19. మధ్యలో ఆకలేసి తినేసినట్టున్నారు point numbers. Okay. Point number 19. Electrolytic cells. Electrical energy gives chemical energy or chemical reaction. Electrical energy gives chemical reaction. Application. Purification of various metals in metallurgical operations. Purification of metals.
Ma'am, repeat once again.
Applications. Purification of metals. అదే metals చాలే metallurgical operations. Electrical energy gives chemical reaction. First point. Okay. Second point ఏంటంటే అప్లికేషన్స్ చెప్పేద్దాం. అప్లికేషన్స్ ఏంటంటే ప్యూరిఫికేషన్ ఆఫ్ మెటల్స్ ఇన్ మెటలర్జికల్ ఆపరేషన్స్. చూడు, ఏదైతే అంత ఇంపార్టెంట్ కాదో నేను తొందర కంక్లూడ్ చేస్తాను. లెట్ us not be fussy on it. ఏది ఇంపార్టెంట్ ఐ స్ట్రెస్ రిపీటెడ్లీ టీచ్ యూ. ఓకే, డోంట్ వరీ. నెక్స్ట్, electroplating for corrosion control. Electroplating for corrosion control. ఇంకా generation of gases for various applications. Okay, etc. Put it like that. Okay, put a star mark and write. This is what we are concerned in this chapter. Conductometry. Conductometry. Conductometry or conductometric titrations for finding the concentration of test solutions. The star mark is the electrolytic cell construction is what we are using for conductometry titrations, which are used for finding the concentration of test solutions. That's the point with which I want to conclude this. Okay. Now, next. Okay. The conductometry titrations tarvata we'll study in detail experimental part lo. Every chapter has some experimental part, so in that experimental part we'll just pin on what all we want to. Okay, now till this point you have clarity, I suppose. Easy, all are easy points. See what all I was trying to tell you are all the viva voce questions for this conductometry titrations experiments, which are, I think, 2 or 3 experiments are included to you in the syllabus, and these are the viva voce questions. As these points are not covered in your regular syllabus, and these are also important for us to just jump into the exact electrochemistry chapter, what is there in your syllabus. I just took 2 or 3 classes for it. So I felt that probably you will be more acquainted to my way of teaching, which needs some time to get adjusted. Okay, so that's the whole idea. Okay, so I've told the net summary at the bottom. So the electrolytic type of cell construction is what we have for conductometry titrations. Okay, and that's there in the nutshell. What all I'm starting right now is what is exactly there in your syllabus. And I shall start the discussions. Okay, after understanding about the electrolytic cells, I'll talk about, right, galvanic or voltaic cells. Write the heading, galvanic or voltaic cells. Point number 21. Correct? Point number 21. Now come on, tell me, what are galvanic or voltaic cells?
Converts chemical energy into
Spontaneous chemical reaction gives electrical energy.
Yes, correct. Right then. Spontaneous cells in which spontaneous chemical reaction gives electrical energy. Cells in which spontaneous chemical reactions give electrical energy are called galvanic or voltaic cells. But usually, what's the point I'd like to share with you is that, see, one point is there. In general, I always say a galvanic voltaic cell as an electrochemical cell. So, in general convention in our colloquial way of understanding the topic, it is like a galvanic cell or voltaic cell is not generally addressed. It's just like electrochemical cell. Means they mean galvanic or voltaic cell. The name is given after the 2 scientists, Galvani and Volta, who contributed to a great extent about these electrochemical cells, in which a spontaneous chemical reaction is getting the electrical energy. Okay, so I took 2 metals. Okay, iron and copper. Or aluminium. Out of these 3 metals, which do you think are undergoing corrosion very, very quickly?
Iron.
To understand.
Iron.
Iron, huh? Enduku? Why? One more question to answer. Oxidizes. అంటే నీ ఉద్దేశంలో కరోడ్ అయ్యేవన్నీ తొందరగా ఆక్సిడైజ్ అవుతాయని అని కరెక్టా? కరెక్ట్, దట్స్ ఆన్సర్. రైట్ ఆర్ రాంగ్? నీకు ఐడియా ఉన్నది ఫస్ట్ ఎక్స్ప్రెస్ చేయాలి. అది రైట్ అయితే గుడ్, రాంగ్ అయినా వెరీ గుడ్. నీకు ఇప్పుడు కొత్త ఐడియా వస్తుంది అంతే. ఓకే, which metal is used for power supply, high tension wires? ఏ మెటల్ వాడతారు? కాపరా?
Copper.
ఎలక్ట్రికల్ లైన్స్, పవర్ ట్రాన్స్మిషన్ వాడే లైన్స్ ఏంటి? కాపర్ వైర్సా? Aluminium wires are
Aluminium also sometimes.
No, sometimes it is aluminium. They are white, మెరుస్తుంటాయి. They are aluminium wires coated with aluminium oxide compounds. Why we'll discuss later. Again, that is there in corrosion topic. Why aluminium is used in spite of copper being the best conductor of electricity? Why? అంటే ఏదో ఇచ్చి వాళ్ళకి because it doesn't suffer much corrosion as compared to copper. So it's now I'm talking about a natural experience that when we look around us, we are seeing few metals are undergoing faster corrosion. It means they are undergoing faster oxidation than those metals like copper or aluminium, which are suffering less corrosion. That means that they are getting very slowly oxidized. That means by this time, I have understood that not all, every metal have their own oxidation potentials. That means they show the tendency to whether lose or gain electrons in a very unique way. Okay. So, a spontaneous chemical reaction is taking place and I'm getting electrical energy. That's not an easy word to say. The rusting of iron is a spontaneous chemical reaction there, but am I getting electrical energy out of it? Or what I have to do to get electrical energy from spontaneous reactions that are happening around? How? I know. For that, I took two metals like zinc and copper. Okay. It took two metals, zinc and copper. What is your guess? Which metal will undergo faster corrosion or faster oxidation out of zinc and copper? How to guess all these things?
Copper, zinc.
With the help of SRP values, we can tell, ma'am. Oxidation.
How we are getting SRP values, Neeraj? What it means by that SRP value you are using so many times? అంటే ఏంటి అసలు ఎలా మెజర్ చేశారు? How this happening around?
With the reference of hydrogen, ma'am.
Hydrogen gas electrode. ఏది యానోడ్ ఏది క్యాథోడ్? అసలు ఏమి ఉండాలి? So, I'll tell you one.
Copper, ma'am.
Copper. I think it's almost time. I need to take my attendance. Okay. I'll start my discussion. I want to get electrical energy and use them as my batteries. Okay. Fine. And have to club two things. Okay. Why? For flow of charge, what is important? First point you should tell me. What is very important for flow of charge? Hey, I've already told this to you all. Click kavali brain. These are Viva questions only. What is required for flow of charge? A copper wire will not give a shock if you touch it normally. But when you just plug in, it will give a shock. Why? So what is required for flow of charge?
Potential difference.
Potential difference.
Thank you so much. So for flow of charge, you need a potential difference. Okay. Now that's the first point you should have. So that means there should be two ends which are at two different points. Potentially there are two at two different points. Okay. So I'll make 2 points. Okay. And I'll create a potential gradient so that the electrons flow from one end to the other end. Fine. That's the first point. I just put it in my brain that I need 2 points which are different. That means there can be a chance for flow of ions from one place to the another. Okay. Then, okay, fine. I've understood that what are spontaneous chemical reactions happening. So what are spontaneous chemical reactions? The reactions in which there is no necessity for supply of any external energy for the chemical reaction to take place, are all supposed to be spontaneous chemical reactions. That means a reaction which is taking place without the intervention of any external conditions is supposed to be a spontaneous chemical reaction. For example, the rusting of iron itself is a spontaneous reaction, but the rate of reaction is exorbitant. But what I would do, I would choose such a chemical reaction which takes place at a reasonable rate and doesn't need any external interaction or intervention for the reaction to happen. Okay, so that's another one. So, okay, I want a chemical reaction which takes place spontaneously, and from that chemical reaction, I would like to have electrical energy. I understood that for getting the electrical energy, I need to make the electrons flow from one end to the other. That means I need to take 2 points, one as anode, the other as cathode. Why? Anode place there is always loss of electrons, and there is another point at a cathode to which electrons would move. So the electron flow should always be from anode to cathode. Okay, and that's how I'll set my cell. How? I'll understand all the chemical reactions which are taking spontaneously, and during that chemical reaction, at one point the electron should be lost, and the other point the electron should be gained. One will be anode, the other one will be cathode. I'll connect the electrodes with the help of wires, and I'll make the electrons flow. I need an electrolyte. The electrolyte is what is the chemical reaction under consideration which will have a spontaneity for the generation of power. Okay, this is what exactly is a galvanic or voltaic cell. Okay, I'll just continue tomorrow because I think at 11:10 you will have another class. What's the next class you have?
EPS.
Yes, class. Okay, I think you'll get late. Tomorrow we shall discuss. Tomorrow you don't have a class. Saturday. Okay, I think on Tuesday. 3 classes have gone, and I think this is the 4th class where I'll be starting my syllabus from Tuesday. Fine, no problem. But then you should understand the basics clearly. Then we can just manage. Okay. As soon as you give your attendance, you can leave the class. Okay. And good day to all of you. Roll number 61. 61 is absent.